Okay, and good afternoon. Today we continue with the questions. The questions I gave you the past question. Okay, and the question we do question number 2, structure question, paper 2, this paper 2, structure question number 2, okay, and we continue with the questions now. Okay. Question number 2. Question number 2. Diagram 2.1 shows a light ray passing into a diamond. What is meant by critical angle? What the first question? What is meant by critical angle? Critical angle means the incident angle when the refracted angle is 90 degrees. Okay. Critical angle means it's an incident angle. It is an incident angle when the refracted angle is 90 degrees. Okay, I go through. I think I go through with you last objective questions. I go through the three aspects of the critical angle, or maybe the incident angle less than critical angle, incident angle equal to critical angle, incident angle is more than critical angle. So this our not this one. So this one. Let's say this is maybe 33. This is I. This I equals to C. Let's say the I equals to C. The I equals to C. The I equals to C. Let's say 33 angle is an incident angle. Happen to be same as a critical angle. The refracted angle. This one is. So the refracted angle is making 90 degrees. So the light ray refracted on the surface. But one thing you must understand, this one must be water to air. So the light must travel from higher density to lower density. Okay, the light ray must travel from higher density to lower density. That's how we call it. We call it a critical angle. So the incident angle equals to critical angle when the light ray refracted 90 degrees to surface. Okay, 90 degrees. So the light ray must travel from higher density to lower density. Okay, this is we call a refracted. Okay, what is meant critical angle? The incident angle when the refracted angle is 90 degrees. Okay. Second question. Calculate the critical angle of the diamond. Refractive index of diamond is 2.42. So we must use the formula n equals to 1 over sine c. So the refractive index is 2.42. Refractive index n 2.42. This is 1 over sine c. So the cross multiply sine c equals to 1 over 2.42. 1 over 2.2. C, critical angle C. C means critical angle. The critical angle according to my answer is 24.4 degrees. 24.4 degrees. That's critical angle. 24.4 degrees. Okay, question number C. Complete the path of the light ray in diamond until it finally emerges out from each object. Until it finally emerges from object each object something. Until it came out from the diamond. So this one you must understand. This is very, very important. So the critical angle of diamond. The critical angle diamond is 24.4 degrees. The critical angle of diamond is 24.4 degrees. This is a Okay, diamond like this. Okay, and this is the normal line. Any light ray you want to draw, you must draw with a normal line. Normal line. The light ray you must draw with a normal line. Okay, and okay, the light ray is like this. Okay, this light ray. Okay, this light ray. Okay, and this normal line. Okay. Okay, this is normal line. And the angle they given 30 degrees. This is a light ray. This light ray they give us this. Okay, this angle 30 degrees. The angle they give 30 degrees. The angle of incidence is 30 degrees. This is a light ray. They give this light ray. So now we have to draw the light ray until it come out from the object or it come out from the diamond. Okay, 30 degrees. Is this eye? This eye. This eye. Eye 30 degrees. So eye is more than critical angle. Eye is 30 degrees. The critical angle is 24.4 degrees. The critical angle of diamond is 24.4 degrees. So the incident angle is more than critical angle. The incident angle more than critical angle. When the incident angle more than critical angle, the light ray experiences total internal reflection. The light ray experiences total internal reflection. So the light ray, okay, like this. Okay, like this. Total internal reflection. So the what do you call it? The R also 30 degrees. The R means refraction angle. The angle of refraction. Angle of refraction also R is 30 degrees. Angle of reflection, angle of reflection. The incident angle 30, angle of reflection must be 30 also. But the incident angle more than critical. So the light ray experiences total internal reflection. So I saw a note, I saw this note. This question came out before. They say in the schema jawapan, I think schema jawapan, they say you must draw two light rays, at least two light ray for internal reflection. For total internal reflection, at least two light ray before the light ray come out from diamond. Two light ray. So this one light ray. Okay, first light ray and the second light ray. The second light ray. Okay, that is second light ray. Okay, this is normal light ray. So the angle of incident. Angle of I is equals to R. I equals to R. So this is a normal line. Okay, and the light ray. Okay, this light ray. Okay, and the light ray. It's the light ray. Okay, like this, because it's not straight light ray. It's not straight light ray. It's something like this one, and come out from the what do you call it? For angle, because the light ray is traveling from diamond into air. Diamond into air. Higher density into lower density. The light ray come out from diamond. So air. So air must be the angle of reflection. angle of refraction, angle of refraction. This one is angle of reflection. Reflection, because total into reflection. But now the angle of refraction must be more, away from normal. The angle of refraction away from normal, because the light ray traveling from diamond to the air. So the angle of refraction, this one, angle of refraction must be more than normal, or away from normal. This is a light ray. So like this. So this is one total into reflection, another total into reflection. This one total into reflection. This is total into reflection, another one total into reflection. Total into reflection, another one total into reflection, then the light will come out. So at least minimum. You can draw like this also can come. You can draw like this, it come out. So it can minimum, you must have minimum 2 light ray total into reflection. Minimum 2. So 1 and 2. And it come out from the medium. Density, higher density, lower density. Diamond to air, come out from medium, emerge out from the medium, they say. So it may be away from normal. Towards normal means directly towards normal. And towards normal. Okay, towards normal. So away from normal. Because light ray is traveling from higher density to lower density. Diamond to air. So away from normal. Okay, that's it. That's the question. And now we are going to do question 4. Question 3. Question 3 is electromagnetism question. Okay, and okay, we do question 3. Diagram 3 shows a bar magnet is being pushed towards a solenoid. What is meant by electromagnetic induction? What is meant by electromagnetic induction? Okay, electromagnetic induction. What is meant by? Okay, production of induced current. Production of induced current by the changing of magnetic field. Production of induced current by the changing of magnetic field. Okay. Okay. Next question. Okay. And next question. What is the state the polarity X when the bar magnet is moved towards solenoid? Okay. Okay. Now this one is a bar magnet. This one is a solenoid. Solenoid. Is solenoid. This is a galvanometer. We put X. So they put the bar magnet, north pole and south pole. So the push in. So according Lenz law, you learned Lenz law before. When they push in the magnet, the poles must be same. So the pole X must be north pole. So we learn Lenz law. Lenz law states that the induced current flows such a direction opposed to the change that producing it. So north and north. So north and north is opposed belentang. So when you pull out the magnet, north pole and south pole. When you pull out the magnet, opposite direction, opposite poles. Pull out the magnet. This one push in the magnet. The poles will be same. You remember that? Okay. When you pull out, the poles must be different poles. The poles north and south. Okay. But you must see the pole of the magnet is opposite. Opposite to the coil. what do you call it, facing the coil, facing the pole of the magnet facing the coil. Don't see this pole, don't see that pole. The pole that facing the coil, the pole that facing the coil. So the coil X must be north pole, X must be north pole, because push in the magnet north pole and north pole. Okay, and question number C, in diagram 3, when the magnet is pushed towards the solenoid, mark the direction of induced current on the solenoid. Marks the direction of induced current on the solenoid. Okay, this the current must be like this, 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 like this. This is current. This is current. This current. This is the direction of current. Must be go up like this. Okay. If you want to see the length slope, if you want to see the length slope, okay, if you got north pole, because it's pushed in the magnet, north pole and north pole, north pole and north pole. So then you must use a right hand grip rule. Right hand grip rule. The right hand grip rule is one right hand grip rule like this. The wire, straight wire, right hand grip rule. The current go up and there's a magnetic field, the direction of magnetic field. This is straight wire. But this one is solenoid. Solenoid also using right hand grip rule. Solenoid also using right hand grip rule, but the forefinger shows direction of current and the thumb shows direction of pole, north pole. Direction of north pole. So north pole is here. North pole here. So that's north pole. So like this. So maybe like this. Okay. This is like this. This is fingers. This fingers go like this. Finger go like this. So this current. Current go up. Current go up. Current go up is north pole. So direction north pole. So north pole we found this earlier. We found north pole is here. So the current must be direction. Current must be direction. This direction, north pole. This north pole because north pole here, the magnet. It's a Lenz law. According to Lenz law, when you push in the magnet, the poles will be same. North pole, north pole. Okay, so the current direction is the right hand grip rule. Right hand grip rule, the forefinger shows direction of current and the thumb shows direction of north pole. The thumb shows direction of north pole. So it's four fingers like this. This. So current is like this. So sorry, current is like this, four fingers, current pole go up and come down, and the north pole is direction of north pole, or north pole is must be what do you call it, north pole, north pole. Okay, north pole, north pole. This is north pole. This thumb shows north pole direction. So this is current direction, and show the direction of the pointer on the zero galvanometer. Okay, the current go like this, come like this, like this, like this. This current go like this, and like this. So the pointer shows like this. The pointer shows like this towards this current. If the current flow this other way, does the pointer show like this. This pointer now show like this. So like this. So its current flow like this. The pointer push in, the pointer push in. So this is a pointer direction. You must remember direction of pointer. You know this always. They always ask question in exam. Direction of current, direction of pointer. Okay. If a current is flowing like this, coming down, so the current like this. Current go like this. So current go like this. This pointer go like this. Pointer go like this. Okay. Now the current go like this. Go up. Go up. Okay. So the pointer show like this. Pointer show like this. So this is the answer. How the answer. Okay. And state one method to increase the induced current in the solenoid. One method increases induced current. One method. What method? One method is what? Use a stronger magnet. Use a stronger magnet. Another method. Number of turns of coil increases. Number of turns of coil increases. Okay. First method, use a stronger magnet. Stronger magnet. Second method, increase number of turns. Number of turns. If, for example, 4 5 turns, you might put 10 turns, 30 turns. So you put increased number of turns. So that another thing, another one. What do you think? Another one. Use stronger magnet. Stronger magnet, you push the stronger magnet, you cut the more flux, so produce induced current more. Increase induced current. This is answer for first answer lah. Or another method, increase number of turns. Increase number of turns. Another method, increase the relative speed. Push in the magnet so fast. You push the magnet faster. You push the magnet faster, then can cause induced current, higher induced current. Okay, push in the magnet relatively fast speed. See, so the speed, increase the speed of the magnet. There is three method can increase what do you call it, induced current. Increase the magnitude induced current. Okay, and then question number E. Name the physics law involved determine the pole. Determine the pole, the North Pole. What is the physics law involved? Lenz's law. Okay, and so we are doing so many questions, multiple questions. That's the Form 5 question, Form 4 topic questions. Like this, we do more questions. The more we do questions, the more we are better. We are getting ready for the exam. Okay, but I'll maybe one paper, two paper we set these questions. But beside, I will even though one question, in that one question I will link to the other questions which can possibly can ask these questions from this question. Okay, for example, one question. From one question, maybe I thought this one. For example, the current direction change, pointer change. So if you opposite direction, for example, pull out the magnet. So these are the questions. This question, what is the pole of the magnet? They ask you when they push the magnet. They never ask when they pull out the magnet. But I told you, pull out the magnet. In pull out the magnet, north and south pole. Pull out magnet. The magnet is pull out. So this is how we do questions. For one question, we link other possible questions. So like this, based on God's grace, my experience, so I will show you or I will teach you some other questions. So like you are doing 3 paper, 4 paper like this. Okay, like this paper, 3 paper, 4 paper, you do like this. Like something like I share with you information. I share with other questions possible questions, other questions I've gone through before. Okay, I will share with this one question. Okay, like this, like you are doing 3 paper, 4 paper, you are doing more papers, something like that. Okay, question number 4. Diagram 4.41 shows a cylinder's gas tube and uniform cross-sectional area of 3 cm square. The glass tube contains lead shots and floats upright in water. Okay, what is meant by density? The first question. Mass per unit volume. Mass per unit volume. That's called density. Question B. Mark the 2 forces act on the glass tube. Mark the 2 forces. Okay. This one is another interesting question. You need my help lah. You need my help to do the questions lah. Okay, like this. Lead shots. Okay, this is water. Okay, this is 10 cm. This is 4 cm. So they mark the 2 forces. The first force first force weight and the second force FB. So you can write like this, W equals to weight. FB is a buoyant force. So the weight is acting downwards, buoyant force acting upward. These are two forces. Two forces. Okay, it is a floating upright. It's not sink completely. It doesn't immerse completely. The tube doesn't immerse completely. So that means we can understand one thing. The weight must be equals to buoyant force. The weight equals to buoyant force. If the buoyant force is more than weight, if the buoyant force more than weight, if the buoyant force more than weight, what happened? The object floats. The object floats on the surface. The surface. The buoyant force lesser than weight. Weight is more than buoyant force. The object immersed completely. The object immersed completely. In this case, the buoyant force equals to the weight of the object. So the object floats. This float means floating floating on the surface. Floating, something like terraform, like float. The float. The put it in the float in the what do you call it? In the water, float. So that's called the object floats. The object floats upon the surface. That is called different. But this floating different. This floating partial immersion. This is called floating or partial immersion. Partial immersion means the weight of the object must equal to the buoyant force. The weight of the object equals to buoyant force. So this is called partial immersion. Partial immersion or floating. Okay. Next question. Density of water is 1 gram per centimeter cube. Calculate the total mass of the glass tube and the legs of. Okay, now this question interesting. This question interesting. They are asking the weight. Okay, so the weight equals to buoyant force. This question number 1. B, C, C1. C part 1. So the weight equals to buoyant force. The weight equals to buoyant force. The weight must be the mass times G. Mass times G. The mass must be this mass. This mass will be the mass of the glass tube and a lead shot. Lead shots. This together, the mass of the tube and the lead shots. Mass together. The mass of glass tube and the lead shots. This mass times G. M equals G. And the buoyant force rho V G. Rho V G. The rho is a density. Because this question is a very different question. The density they give gram per centimeter cube. The density they give is gram per centimeter cube. Actually speaking, the density is kilogram per meter cube. SI unit for density kilogram meter cube. Since they give, normally they give kilogram per meter cube. I don't know why they give gram per centimeter cube. They give gram per centimeter cube is not SI unit, but it's a density unit. So the density equals to the mass times G is 10. G is 10. G is 10. Okay. The density is 1. And the volume, okay, G can cut lah. Can cut G. G can cut here. To put G 10 and 10 on the same G. Cut G. So the M equals to 1 times V. The V is the volume. The volume must immerse portion of the water. Immersed portion of the object in the water. Immersed portion of the object in the water. So since the density gram per centimeter cube, volume also must be centimeter cube. The volume also must be centimeter cube. So the volume is 10 cm times the cross section area of the tube. We have the given cross section. Cross section area 2. Given cross section area 2. The cross section cross section area is 3 centimeters square. So it's a 3 centimeters square. It's a volume. Volume is height of the object, height of the immersed portion of the object times the cross section area. Height times cross section area. That's called volume. It's a volume of the we call it cylinder, volume of cylinder, something like that. Okay. So this n equals to is 1 times centimeter. Centimeter is okay. I'll give the unit so that you know this why I must change to gram per centimeter cube, or the density gram per centimeter cube, the volume must change to centimeter cube, because if the density kilogram meter cube, the volume must be meter cube. If the density kilogram per meter cube, the volume must be meter cube. Because the density gram per centimeter cube, the volume also must be centimeter cube. So for example, 1 gram per centimeter cube. Okay, is m equals to, so this one centimeter square. So centimeter cube, centimeter cube. So 1 gram times 10. 1 gram times 10 is 30 gram. This is nice, 30 gram. 1 gram left, the unit left, gram. This one gram per centimeter cube density. So it's a 30 cm, 10 cm times 3 cm square. So cm and cm square is cm cube plus cm cube cancel. So it's 30 gram. So this one unit, but very careful but normally they use kilogram meter cube, so no problem But volume, maybe the board question. Sometimes I'll give the board questions. The board portion, immersed portion of the board, they give meter square. The what you call cross section of the board, the meter square. Maybe they give centimeter. So you have to change meter. But normally they give, I don't think so. The unit changing is not. Maybe the question they asked this year, maybe this year form 4, maybe the considering unit changing of the unit is important. But your level, I don't think so. Changing units is they ask questions because the kilogram meter cube, the volume is meter cube. That's all. You must remember that. Kilogram meter cube, the volume meter cube, that's all. Okay. And 30 gram, okay. Question number 2. In the tube is then placed another liquid of greater density. Determine what happened to depth of a glass tube immersed. Okay. Determine what happened to the depth of the glass tube immersed. So depth of the glass tube immersed decreases. For example, this density water is water. So they give another tube, maybe same tube. Okay, the tube that is. Okay, so this is a higher density higher. The water or liquid is a higher density. So the boat, what do you call it, the tube floats higher, or immersed portion. They are asking the question, determine what happened depth of glass tube. The depth of glass tube decreases. So maybe, for example, maybe 8 cm. The depth is 6. Maybe 8 cm, 10 cm, 40 cm, so maybe 6 cm here, 6 cm here. So it floats higher. It floats higher. This liquid higher density, the glass tube floats higher, or the immersed portion, the depth of the glass tube decreases. For example, 8 cm. Because it's higher density, floats higher. Higher density is more than density water. Okay. And question number, state the reason for the because the reason because the Okay, this is buoyant force. Buoyant force equals to rho Vg. When the rho increases, when the rho density increases, the buoyant force also increases. So buoyant force push up. The buoyant force push up the glass tube, push up. So it flows higher, or the depth of the glass tube lesser. Immersed portion lesser. Stencil immersed, ACA immersed only. So less portion. So it flows higher. Flows higher. So when the density increases, buoyant force increases. Okay. So the answer is we can say when the density increases, buoyant force increases. That's the answer. When the density increases, buoyant force increases. So buoyant force push up the object. Push up the object. Okay, next question, question number 5. Question number 5. We do so many questions. We do slowly, never mind. We do slowly. Never mind. We do slowly because we are learning something. We are learning some revision. This is revision class. Okay. I don't rush in doing question, finishing question, giving answer. That's not the point. That's not the point. Giving answer, I can give the answer on the spot. But that's not the point. But we do revision, we do some revision from one question, we do revision other questions linked to these questions. So we do slowly we do it. Okay. Question number 5. Diagram 5.1 and 5.2, two different wheelchair, mass and the wheelchair and the man are same. Wheelchair and the mass of the man same. Another word, weight same. Another word, weight same. Okay. What is the meaning of pressure? What's the meaning of pressure? Pressure means force per unit area. Force per unit area. Okay, that's what it's called pressure. Force per unit area. Okay. Next question. Okay, next question. Based on the diagram 5.1 A and 5.2 A, compare the weight of the wheelchair. The weight of the wheelchair must be same because mass same. The weight must be same, mg, right? Mass mg. Okay, next one, next question. Compare the depth sinking of the wheelchair. Depth of sinking. Depth of sinking. So 5.1 sink more than 5.2. In 5.1 sink more. The weight sink more. The weight pushing the wheelchair, the weight of the man pushing the wheelchair to sink more. So the wheelchair sinks in 5.1 is more than 5.2. The wheelchair in 5.1 sink more than 5.2. The wheelchair in 5.1 sink more than wheelchair in 5.2. Okay. Next question. Compare the area contact with the ground. Compare the area. So the area. So the wheelchair is area. Wheelchair is area small wheelchair. Something like this wheelchair. Yeah? This wheelchair is this. This is 5.1. This 5.2. So it's more cross section area. The wheelchair is a small cross section area. Area is small. This area is big. This area is small. This area is small. This area big. So we can write the answer. The area of contact in 5.1. Area of contact of the ground. Area contact with the ground. Area contact. The wheelchair contact with the ground. The area of contact. The area of contact with the ground in 5.1 is smaller than 5.2. You must write the first question, you write 5.1, Then the subsequent question 5.1, 5.1, 5.1. So it must be something like that. So then you can see the link, then you can see the correlation there. So you don't say 5.2 is bigger than 5.1. So because the first question is 5.1, what do you call it? The sync more in 5.2. So you wrote 5.1 is more. So the subsequent question 5.1, 5.1 like 5.1. Okay. So 5.1. So the area of contact with the ground in diagram 5.1 is smaller than 5.2. Smaller than 5.2. Okay, smaller than 5.2. Area of contact. Next question. Relate the depth of the sinking and the pressure. Sinking and the pressure. So the higher the pressure, the higher the pressure, the higher the sinking. Higher the pressure, the higher the sinking. Sinking of the wheelchair. Higher the pressure, the higher the sinking of the wheelchair. Okay, next question. This one is you must understand this. For example, question 5. You must read through the whole question. I taught this one before. You must read through the question. Question A, question B1, B2, B3, B4, B5. You must read all the questions first before you start answering back. You don't answer question A, answer 1. Question B1, answer 1. Then questions B3, I don't know. We don't know, go back. So you must understand. You must read the whole question before you start answering question one by one. Before you start answering the question one by one, you read the whole question first until question number B4, B5 or E1, C1, C1, C2. Read the whole question. You read the whole question. Then you can get some idea of this question. What is all about this question? What all about this question? So this question is a pressure and area. So this question is a pressure and area. This one you understand the question. You read the question, then you understand the concept. Then you go back again. Question 5, A1. I answer A. B1, B2, B3, answer A. So I will teach a method for you. Before you start answering the question B1, B2, B3, you read the whole question first, one glance through all the question, whole question glance through. Then you go back again, question 5A, 5B1, 5B2, answer this. Then that means you can understand this concept about this question. Okay. Because I have gone through this before, I don't go through the question because but when you do SPM, when you do exam, you must go through the whole questions. Okay. Rate depth of sinking and the pressure. The higher the pressure, the higher the sinking on the wheelchair. And question 5, name the physics concept involved. What is the physics concept? Okay. Physics, the concept is pressure. They never ask law. They are asking the concept. So the pressure influenced by the area, surface area. Pressure is influenced by surface area. Pressure influences the surface area. The bigger the area, the smaller the pressure. So that's why the wheelchair, the bigger wheelchair, sink lesser. 5.2, bigger wheelchair, bigger area. Bigger area means pressure is lesser. Pressure lesser. Pressure lesser. So it sink lesser. This one, the area small. The area small, the pressure high. Area small, pressure high. So that's why they sink more. Sink pressure. Pressure more. So they sink more. So this is how we can understand the concept. Okay. So the name, the physics concept involved. Pressure is influenced by surface area. Predict what happened to the pressure when the mass of the wheelchair increases. Mass of the wheelchair increase means the weight of the wheelchair increases. When the weight increases, when the weight, the F equals to weight, the force equals to weight. Force equals to weight. Pressure equals to force or area. Force equals to weight, the weight. So weight increases. Weight increases, pressure increases. Weight increases, pressure increases. The mass increases means weight increases. Weight increases means pressure increases, because pressure and the weight is directly proportional. Pressure and the weight directly proportional. Pressure and area inversely proportional. So when the area increases, when the area increases, pressure decreases. Area decreases, pressure increases. These are pressure and area inversely proportional. Inversely proportional. Pressure and the weight, or pressure and the force, must be directly proportional. So force and weight same, because same carry same unit Newton. Force also carry Newton. Weight also carry unit Newton. So force and weight is same. So directly proportional. Okay. Explain your answer. So when the mass increases, explain answer. When the mass increases, the weight of the wheelchair increases. When the weight increases, pressure increases. That's how they explain answer. Okay, question number 6. Question number 6. Question number 6. Okay, question number 6. Okay. What is meant by semiconductor? Figure 6.1 and 6.1a and 1b menunjukkan dua lethal electric mengelilingi dua daya semiconductor. So daya semiconductor. Okay. What is meant by semiconductor? Material that has a resistance between good conductor and the good insulator. Semiconductor means material that has resistance, and that has resistance between resistance of good conductor and the resistance of insulator. Okay, material that has resistance between the resistance of good conductor and the resistance of good insulator. That's called semiconductor. Okay, this one, read the question B1, B2, B3, B4, B5. You must read the whole question before start answering. Whole question before start answering, because you try to understand the concept what the question asking you. Okay, compare the lighting of the bulb. Okay, this is the lighting of the bulb. This bulb is light up, and this bulb doesn't light up. Okay. Okay, this bulb light up. Because why? 6.1, I say 6.1. This one 6.1, 6.2. This one current is flowing. Current is always must flow from positive. So current is flowing. Forward bias. Diode forward bias. So the bulb light up. This one is reverse bias. Current cannot flow. So reverse bias. This one forward bias. This one reverse bias. So current cannot flow this opposite direction. Okay, and compare lighting of the bulb. Bulb in diagram 6.1 lights up. Okay, lights up. And light bulb diagram 6.2 is off. Compare the circuit. Compare the current. Okay, current in diagram 6.2. Okay, current in diagram 6.2 flows through the bulb. In diagram 6.2, current doesn't flow through the bulb. Okay, compare the current. Current in 6.1 flow through the bulb. 6.2 doesn't flow through the bulb. Question number 3. Compare the way the diode is connected to the terminal of the battery. the way the diode is connected to the terminal of the battery. Okay, in 6.1, diode connected 4 bias lah. In 6.1 diode connected 4 bias. In 6.2 reverse bias lah. Reverse bias. Question part 4. Relate the lighting of the bulb and the way the diode is connected to terminal of the battery. Okay. When the diode is in forward bias, bulb lights up. Question part 4. When the diode is forward bias, bulb lights up. Question 5. Name the physics concept involved. What is the physics concept? Diode allows current flow in one direction only. Part 4. Diode allows the current flow in one direction only. Let's call it okay. And question number C. Part C. Diagram 6.3 shows a circuit connected to the cathode ray oscilloscope. Draw the traces shown on the CRO. Okay, it's question C. Okay. Okay, this one is CRO. Okay, this one AC current positive. So current cannot flow like this, but current can, and AC current will change directions. AC current, so this one become positive, this one become negative. So current flow like this. Current can flow like this. Current can flow like this. Current can flow like this, but current cannot flow like this. So the AC diagram, the AC like this is current like this, or maybe current like this. This one like this. So this current doesn't flow. Current flow like this. So this one doesn't flow like this. Doesn't flow like this. This one half wave rectification. This is called half wave rectification because current doesn't flow. When it's positive here, current doesn't flow. But positive, this change direction, current flow can flow. So it's a half wave rectification. So explain the answer. Okay. In first half, the diode is reverse bias. In the first half, diode is reverse bias, no current flow. In the next half, diode in forward bias. The next half, current can flow like this. So current can flow like this. So next half, current can flow like this. So this diode can be forward bias. Current can flow like this. Positive here, negative. So change again. This one positive, this one negative. So the current cannot flow. Current cannot flow like this. So it's a positive again, negative. Then current can flow like this. Current can flow. So half diode, half wave rectification lah. So in the first half, diode is reverse bias, no current flow. The next half, diode is reverse bias. In next half, diode is forward bias. Current can flow lah. Current can flow. This is question 7, 8. Because question 7, 8 need so much explanation. Because this question is spring question. No, I want to teach you spring. I want to teach you spring more than this question. So I will teach you next day lah. Okay, maybe another day. Maybe this week or maybe another day. Maybe I'll teach this question. Or maybe another week next week. Maybe I will teach you the questions. Okay. And rest of thank you very much for that.